Hey, good afternoon. This is Professor Villa, and we are coming to you live from the UCC Chemistry Lab. Today we're going to be doing a lab called Atomic Structure, and so we're going to start looking at the atom, we're going to start looking at elements, and some of the different characteristics as we work our way through the periodic table, that giant Tetris thing up on the wall. As we know from the periodic table, there's 118 elements that are known today. That's probably going to change in the next couple of years as scientists are already working on discovering the next elements. That would be possibly 119, numbers 120. You know, when we look at some of the elements, some look like each other's, and then there are a couple on there that are just kind of off and doing their own thing. About 1869 was when the Russian chemist Dmitry Mendeleev kind of first came up with the idea for the periodic table, proposing that elements should be listed on the table in order of their increasing mass. A few decades later, 1913, an English physicist, Harry Moseley, found that the elements should be actually arranged according to their increasing atomic number. And so that's what's known as the so-called modern periodic law, which that the properties of the elements that we see, there is a recurring pattern when we place them on the table according to that increasing atomic number. And so periodic just means that there's this regularly repeating pattern. And so the table itself is arranged such that the elements are placed in order of increasing atomic number. Groups, or the vertical columns on the table, are arranged so that atoms and elements within a group have similar properties. Each box on the table has some information in it. It contains the element's symbol, contains its atomic number, the average atomic mass, and then sometimes it has the element's name. So there's 7 horizontal rows on the table. Those are called periods or series. And then there's 18 vertical columns, which are called groups or families. And so there's a couple different naming systems or numbering systems for those groups or families. The first is in the United States. We label those with a Roman numeral and then a capital letter, either A or B. So Roman numeral 1 through 8A and Roman numerals 1 through 8B. And then the IUPAC, the International Union of Pure and Applied Chemists, recommends that the columns be labeled 1 through 18. And so you might see some tables that have one of those or both of those, but that's different ways of naming that. So today's lab, we're going to be looking over some different elements. We're going to be looking at some properties of different elements and atoms, and as we work through some of those characteristics that we see. Again, it's not wanting, I'm not wanting you to memorize the periodic table because I haven't done that, but it's knowing patterns that we see in the table. What are those repeating patterns that the early scientists discovered? And if we know where an element sits on the periodic table, what can we predict about its behavior, right? If it's over on the far right, what does that tell us? Or if it's over on the far left, what might we know about those elements? And so we'll talk about all that. So enjoy. So the first part that we're going to do in the lab today is what's known as a flame test. And in a flame test, this is where we take a sample of an element and we put it into a hot flame. And what we're doing, because what we know based on the atomic structure, is that when we put that sample into the hot flame, we're going to excite the electrons. And the electrons are going to get excited and they're going to jump up to the next highest shell level. And then they're going to relax and they're going to want to get back to where they wanted to be. I kind of talk about how when you're climbing up a ladder and you get to that very top rung on the ladder, the one that says this is not a step, but how many of us have actually used that as a step? But when you're standing on that very top rung of the ladder, you kind of feel a little wobbly and maybe a little unstable, and you think, maybe it might be a better idea if I took a step back down, then I'd have a little more stability. And so electrons kind of do that same thing. They jump up to the next highest level when we excite them with heat, and then they want to get back to that lower level, that more stable level that's a rung below them. Well, in order to drop back down, they have to release energy. And when they release energy in the form of light. And depending on how big of a jump those elements make, well, that is characteristic of what color of light they emit. So different elements will emit different colors of light. And that was one of the ways that the early scientists were able to classify different elements or identify unknown samples of elements, is taking a sample, exposing it to a hot flame, and seeing what color of lights were emitted. So we're going to be taking some different known samples, elements that we know their identity, and seeing what color we get characteristic of that element. And then we're going to have some unknown samples, and we're going to try and match up the unknown samples to the samples that we do know. So that will be your task, is trying to figure out the identity of the unknown samples that will be presented to you. So again, hope you have fun. Okay, so there's my flame, my blue Bunsen burner flame. And so as we work through this, kind of a couple things to note is that when we stick the popsicle stick, we've got little splints that have been soaked in the different solutions. Then when we put that stick into the flame, the wood itself is going to burn an orange color, but we're looking for the color other than the orange. And again, sometimes it's hard to see, sometimes it's just a quick flash of color. But we're going to do our best to try and distinguish what is the popsicle stick and what is the actual sample. So this first sample that we're going to look at is barium. And so when I put barium into the flame, let's see if we can identify what color we get for barium. Okay, so there's kind of, you can kind of see it. It's not quite that orange color, right? I'm going to call it more of a limey green type of color, a yellowy green. Is the characteristic color of a barium flame. Okay, so the next sample I have is going to be calcium. So we're going to take calcium and we're going to put that into the flame and see what color we get. That one's kind of a reddish orange type of color. Not so much a bright orange, but more of a red orange. Let's see what we get. Let's try another sample here and see. Okay, so there's that kind of reddish orange type of color. It's not the bright, macaroni and cheese orange, but kind of more of a little bit of red in there. Now we're going to try the element copper. Right? Let's see what happens when we put copper into the flame and see what color we get there. Copper should be a nice... Ooh, there we go. That's a really good color there for copper, right? You kind of see that kind of a... I don't know what you would call that. If that were a crayon, what would you call that color? Right, see, there's the orange that's characteristic of the popsicle stick, but the copper itself, right, how would you describe that color there? Then we have a sample of potassium. All right, potassium, also abbreviated K. Let's see what color potassium gives us. It's kind of a really faint color. Might be hard for you to see at home, but here in the lab, it's kind of a lavender hue, kind of a violet in color. If you can see, right, that violet, hints of violet that are present there in the potassium. All right, let's look at lithium now. See what color we get from lithium. Lithium's given us a really nice scarlet red. Some really nice red tones, right? Again, if that were a crayon, right, what would you call that color? Okay, now we have a sample of sodium. Sodium is very characteristic in its color. Right, Right, so there's sodium, the really bright orange color. All right, that's the one I kind of call the macaroni and cheese orange. Right, because if you say macaroni and cheese, you know exactly what shade of orange that is. That's not a color that we commonly find in nature. Right. That's all yellow dye number 5. So there's sodium. All right, and so now we're on to the last sample, and that's going to be strontium. Strontium is going to be the last sample that we look at, and let's see what kind of color strontium gives us. See, that's also another red color. It's not quite the same red that we saw with the lithium. Lithium was kind of more of a scarlet red. This is kind of more of a candy apple red, maybe fire truck red. Although, yes, not all fire trucks are red, and not all red things are fire trucks, but that's there. Okay, there's a good one for that red color that we see for strontium. Okay, so the last part of part A in the lab is that we have to see what's going on with the contaminated water sample. Right? We have to see if it's possible that the liquid we found in the garage was the same liquid that was added to contaminate the well. And so what we're going to do first is we are going to collect and look at the well sample. Right, so this is the well sample that we found, right? And we'll see what color the well sample gives us. What color are you kind of seeing in the well sample? Let's try another well sample and see. Kind of a blue-green type of color. Okay. So we've got some blue-green contaminant that we found in our well. So if you remember, right, which sample it might have been that also was contaminated blue-green. And now we're going to look at the sample that we found in the garage of the teenagers. Right, as it was said, the lousy, good-for-nothing teenagers, right? Those pesky, rotten kids. We found a bottle in their garage, and let's see what color the sample in the garage provides for us. What do you think? Is it a match? Am I seeing the same colors there that I saw in the well sample? Do you think we should file charges? All right, that's your job. And as being part of the crime investigative service. All right. That's part A. Greetings. Now we are moving on to part B of the atomic structure lab, and that is looking at reactions of known solutions. So I have 6 different test tubes, and in each test tube I have placed one of 6 different samples. So in the first one I have barium, and the second one is calcium, then I have lithium, potassium, sodium, and then the last one back here is strontium. All right, so those are the 6 different samples I have, and so to each of those samples I'm going to add a few drops of ammonium carbonate, and we are going to see what happens. And so as I add the drops of ammonium carbonate, you can look to see if you see any changes in the appearance of the sample. So this first one is ammonium carbonate in the barium. All right, what do you see? Next, we're going to add the carbonate now to the calcium sample. All right, then we have lithium, so adding the ammonium carbonate to the lithium. Okay. Then we'll go on to the next sample, which is potassium. Okay, there was the potassium sample. Moving on to number 5, we have the sodium. And then the very last one is going to be the strontium. All right. So there are our 6 reactions, right? Again, we have barium, and then we have calcium, we have lithium, potassium, sodium, and then lastly strontium. And that was with the addition of ammonium carbonate. All right, I have these same 6 samples of barium, calcium, lithium, potassium, sodium, and strontium in fresh test tubes. And now to each of those, I'm going to add a few drops of ammonium phosphate. So ammonium phosphate into the first one. So this is the barium. Here we have the calcium. Lithium. Potassium. Sodium. And strontium. All right, so we have the 6 samples. We had barium, we had calcium, lithium, potassium, sodium, and then strontium. And this is the last part of part B, reactions of known solutions. To each of my 6 different samples, I'm now going to add a few drops of ammonium sulfate. So adding ammonium sulfate to the different samples. So first we'll start with the barium, then the calcium. We have the lithium, potassium, sodium, and the strontium. Right, there we go. So we had the first one, barium. Trying to focus. Barium. And then we have calcium, lithium, potassium, sodium, and strontium. This is part C of the lab, and in part C of the lab we are going to look at some of the different elements. So we have samples, 14 of the different elements off the periodic table, and so I will show you the element, tell you which one it is, and so you'll have to write the name of the element, and then what is its symbol on the periodic table, what is its atomic number, based off the periodic table, and then describe it to me as far as what color is it, what is the luster, right? Luster just means, is it shiny or is it dull, right? That's kind of a subjective thing, but shiny or dull. And then lastly, is it a metal or is it a non-metal, or is it even a semi-metal or a metalloid? So that would go then in the last column. So we're going to do these first few elements, and so I will give you the element and then you'll have to write it in your chart as far as your description. So the first one we're going to start with is cobalt. Cobalt is the first element, and so cobalt, right, there is the sample of cobalt. So you can figure out what you think the color of cobalt is, whether it's shiny or dull, and then if you think it's a metal or a metalloid. And just to let you know, cobalt actually comes from the German word for goblin. So I'm not sure what that means, but yeah, that's where it got its name. So that was cobalt. The next one is a sample of iodine. So this is a sample of iodine. Right, this is iodine, and so you can see the iodine, and it may be hard to see the color on iodine, but it is kind of a purpley color as well, so it's not quite a black, it's kind of a dark purple. So that would be our sample of iodine. Okay. We have a sample of carbon, and so that's a sample of carbon, right, in the form of graphite. Right, that's the same stuff that's in your pencil. Right? It's not lead, it's actually carbon, graphite. And so there's carbon. And describe that, color, luster, metal or not. This is a sample of tin. So that's tin. And you can describe what color it is. Luster, metal or non-metal. Tin. This is a sample of nickel. Right, so that's a sample of nickel. All right, nickel, thank you. This is sulfur. There's a sample of sulfur. You can see that in there. You can see what that one looks like. Maybe, maybe not. Right, you can see kind of a yellowy powder. Kind of reminds me a little bit of nutritional yeast. Not quite. I'm sure it tastes much, much worse. Although I do like nutritional yeast, so, but I don't think I'd like sulfur. This is nitrogen. There's the element nitrogen. And I know it appears to be just an empty container, but it's nitrogen gas. Right, so what color is it? Well, trick question, it's transparent, it has no color. That's nitrogen. This is a sample of silicon. Right, so that's silicon. There we go. Bueno. Right, so that's silicon. Kind of describe what its color is. It does have some neat properties there. Kind of the way it reflects light a little bit, kind of shimmery. Silicon. This is phosphorus. There's a sample of phosphorus. Which is the chemical symbol P. I'll give you that one. We'll talk about that one. You shall never forget phosphorus is P. phosphorus. We have copper. And there's copper. And what color would you say copper is? Well, another trick question. It's copper colored. Right, that was a crayon. One of my favorite crayons in the Crayola box of 64. This is a sample of zinc. So there's zinc. You can figure out what you think: color, luster, metal, non-metal. A sample of cadmium. Well, that's cadmium. You can describe the appearance of cadmium on the periodic table. Here we have lead. Lead, which we no longer use in paint. And the last sample that we have to look at is a sample of mercury. Alright, so that is element mercury. Let me take the lid off of this if I can. Hold on just a sec. Okay, so there's mercury. So right, you can see it in there. It is a liquid at room temperature. Right, one of two elements on the periodic table that's a liquid at room temperature. Shiny, silvery colored. All right, and that's part C. All right, so that's the end of today's lab, the atomic structure lab. There's still some parts for you to fill in. That would be parts D and E, talking about the atomic structure as far as listing what subatomic particles are there, and then also looking at different isotopes and what makes one isotope different from the other isotope. So that will be the last part of the lab, and then there's the post-lab questions that you're able to answer. If you have questions on the post-lab or any part of the lab, please let me know. Send me a message, and I look forward to seeing you again in the next lab.